We will begin by explaining what soccer handball actually is. This sport incorporates significant features from both handball and soccer. The game commences with a jump ball likewise to basketball. One player from each team is sent to the center dot on the court where the ball is thrown up between them. When the ball is thrown, the two players will jump for the ball, attempting to knock it out of the air to one of their teammates. 6 players from each team are on the court at a time, including goalies, and the games are played on hockey nets. The scoring system is fairly simple. To be rewarded with a point, the ball must be struck by a foot or thrown in the net past the goalie. It is only considered a goal when the ball crosses the goal line. Additionally, there is a crease located in front of the net with the dimensions of 6 feet long and 8 feet wide. If the game is transitioned to a soccer style of play, the keeper may not switch to handball if they are outside the crease. Failing to obey this will result in a turnover. Furthermore, the dimensions of the court are NBA regulation, 94 by 50 feet. If the ball is knocked out of bounds, possession is awarded to the opposing team. Lastly, when inbounding the ball, it must be thrown in with feet planted. The team with the most points at the end of the game wins.
For the offense in soccer handball, when your team has possession of the ball, you must play as if it were handball, meaning the ball cannot touch the ground, and each player has a maximum of 3 steps with the ball. In addition, if your team is able to make 5 consecutive passes, you can continue playing handball style, or the ball can be dropped to the ground, switching the game over to a soccer style of play. If the ball is dropped to the ground, the game may not return to handball until a shot is taken on either team's net. Offensive players are allowed only 3 seconds in the crease when attacking the other team's net. On defense, while on defense, you must try to prevent the team from scoring on your goal by means of blocking. When the ball is in handball style, players can defend by trying to block passes and shots with their feet, hands, and body. But if the play is in soccer style, blocking with your hands will result in a turnover. The main objective when the ball is in handball mode is to get the ball to touch the ground, forcing a turnover. When the ball is in soccer style, the defensive team must try to prevent passes and block their shots. If the team with possession of the ball would like to transition from soccer to handball, they must make a pass back to their goalie, where the keeper can then scoop the ball up and make the switch.
Next, let's talk about fouls, penalties, and rules. The accumulation of 2 yellows or 1 red in a match results in suspension for the rest of the game. Travel. When a player takes more than 3 steps while in handball style, this causes a turnover of possession. Body contact. Any attempt to body contact with another player results in a yellow card and a turnover of possession. While in soccer style, any attempt to make a slide tackle results in a yellow card and possession turnover. If a player, other than the goalie, attempts to pick up the ball with their hands during soccer style, then that's a result in a turnover of possession. Reach in. Any swipe making contact with the opposing player in an attempt to steal the ball results in the penalized team taking 5 steps back. If the offensive team has possession and their players are in the opposing crease for more than 3 seconds, then there is a turnover.
Hello, I am Ben Trempf, and I will be explaining how kinetics relates to our created sport, soccer handball. Kinetics is the branch of classical mechanics that is concerned with the relationship between motion and its causes. The first topic that I will be covering is circular motion. The example that I will be using is a game situation where an offensive player is making a curling run around one of his teammates in order to create space. This movement can create space for a pass, shot, or run depending on the situation at hand. To add on, a play of this sort would not be possible without the presence of centripetal force, or FC. As a player continues on their circular path, the acceleration of the player's movement is positioned towards the center of the movement. For centripetal force, this will always be the case. In a movement such as this, the centripetal force is accompanied by the force of friction. When your foot makes contact with the ground, it is opposed by the force of friction, allowing you to stay upright rather than slip and fall. I'll explain another possible case as we move on. According to Newton's third law, which states that for every action force, there is a reaction force equal but opposite in magnitude opposing it. Since both frictional and centripetal forces are positioned towards the center of the movement, the force opposing them is a fictitious force known as the centrifugal force. Note that a fictitious force is an apparent force whose motion is described using a non-inertial frame of reference. Moreover, if the player were to make a curling run and the court had some dust on top of it, the dust would change the coefficient of friction of the playing surface. The dust would reduce the coefficient of friction, resultantly lowering the force of friction, as the two variables are directly proportional to one another. If this were to happen, the force of the player's foot would overcome the opposing static friction, becoming kinetic friction, and the player's foot would begin sliding, causing them to fall. This transition between static and kinetic friction occurs as soon as the foot begins to slide. For our calculation, we will be assuming uniform circular motion. The court we will be playing on is wood, and the shoes are assumed to have hard rubber bottoms, or court shoes. The coefficient of friction between the wood and hard rubber is mu is equal to 0.7, and we will be considering a player would be running at about 15 miles per hour, or 6.71 meters per second, while making about a 75-degree angle between their foot and the ground. This slight leaning of the athlete is essential for helping them keep balance and gain speed. Centripetal force is equal to mass multiplied by velocity squared all over the radius of the motion. Centripetal force is also equal to F net. Furthermore, the force of friction is equal to F net, meaning the following statement is true. The force of friction is equal to centripetal force. Therefore, mu mag cos theta is equal to mv squared over r. In this case, the masses can be crossed out, and we can rearrange this equation to find the radius of the player's motion. The equation when rearranged will be r, or radius, is equal to velocity squared over mu times the acceleration due to gravity multiplied by cos theta. After we plug in our given values, we calculated a radius of motion with the magnitude of 25.3 meters. Next, I will move on to Newton's three laws. Newton's first law states that an object at rest will remain at rest unless an unbalanced force acts upon it. In the case of a penalty shot, the ball is placed on the designated dot and remains at rest until kicked by the player. This means that the net force on the ball is 0. This is because when the ball sits at rest on the dot, the normal force is equal but opposite to the force of gravity, and therefore they cancel out, leaving the ball at rest. Next, we'll move on to Newton's second law, which states that an unbalanced force acting upon an object will cause that object to accelerate in the direction of a force according to the equation F net is equal to mass times acceleration. An example of this would be when a soccer ball is passed from rest. Moving on to the calculation, the force applied by the foot on the ball is 12 newtons. Acceleration due to gravity is 9.8 meters per second squared. The kinetic coefficient of friction between the ball and the ground is 2.5, and the mass of the ball is 0.43 kilograms. Moreover, the force of friction kinetic is equal to mass times acceleration due to gravity multiplied by mu k. The full equation is mass times acceleration, or F net, is equal to 12 newtons, subtract mass times acceleration due to gravity multiplied by mu k. In this case, we are trying to find the acceleration of the ball, so the resultant equation after subbing in our given values would be acceleration is equal to 12 newtons, subtract 2.5, multiplied by the mass of the ball, 0.43 kilograms, and multiply that by 9.8 meters per second squared, or acceleration due to gravity, all divided by the mass of the ball. When calculated, we get an acceleration of 3.4 meters per second squared. Next, we can move on to Newton's third law, which explains that for every action force, there is a force which is equal in magnitude but opposite in direction opposing it. An example of where this occurs is when a player kicks the ball from rest. When the player makes contact with the ball, they feel the force that they exerted on the ball back on their foot. So if the player were to exert 50 newtons of force on the ball with a kick, they would feel that same force back on their foot.
Next, let's talk about momentum/impulses and energy. Momentum is defined as a mass in motion from all objects having a mass, and if that same object is moving, then it has a momentum. Momentum is equal to the mass of the object multiplied by the velocity. To relate momentum to soccer handball, when the ball is kicked at a certain velocity, the ball now moves at that velocity, meaning the ball has momentum. Related to momentum, an impulse is the change in momentum of an object. From the knowledge that we know about impulse, we know that the impulse/change in momentum is equal to the mass of an object multiplied by the change in velocity. Impulse is also equal to the force of the object multiplied by the time it took. By using our impulse equation, we can rearrange to solve for different variables. Let's use an example of a goalie saving a soccer-style kick to further explain how momentum and impulse are in our sport. The ball is kicked at an initial velocity of 26 meters per second forward, which is the average speed of a shot. and we know the average mass of a soccer ball is 0.43 kilograms. While the ball is saved by the goalie, it takes 0.35 seconds to get the ball to the final velocity of 0 meters per second forward. From knowing the initial and final velocities of the ball, the mass of the ball, and the time it took for the goalie to save the ball, we can calculate for how much force that the goalie will experience when saving the ball using the impulse formula. The amount of force that the goalie will feel in his hands from one shot will be equal to the mass times the change in velocity, all divided by the time it took to get the ball to 0 meters per second. The force that the goalie will feel on his hands while saving the ball will be a total of 31.94 newtons away from the goalie. This means that the goalie exerts 31.9 newtons to save the ball, needing to apply a force in the opposite direction to stop the ball. To decrease the amount of force felt by a shot, the goalie could increase the time it takes to stop the ball by moving his hands further back, cradling the ball. The law of conservation of energy states that an amount of energy remains constant and energy is neither created nor destroyed. Energy can be converted from one form to another, but the total energy within the domain remains fixed. To relate the law of conservation of energy to our sport, we can use the example of passing the ball in handball style. When passing the ball in handball style, there is the conservation of energy through the ball. Before the ball is thrown, it initially has gravitational potential energy. The gravitational potential energy is the energy stored in an object as a result of the height of the object from the ground. The energy is stored as a result of the gravitational attraction from the Earth for the object. Gravitational potential energy can be determined by the mass of the object multiplied by the gravity of the planet and finally multiplied by the height of the object. This means that the ball stores energy at its given height. As the ball is thrown from the player's hand, its gravitational potential energy is converted into kinetic energy. Kinetic energy is the energy of a mass in motion and is calculated by 1/2 the mass multiplied by the velocity of the object squared. When looking at the parabolic path of the ball, as it hits the vertex, it begins to slow down, meaning the kinetic energy is converted to gravitational potential energy. After the vertex, the ball begins to fall again. The energy is converted from gravitational potential to kinetic energy.
When relating physics to soccer handball, one must first identify its relation to kinematics. Kinematics is the branch of classical mechanics that describes the motion of points, objects, and systems of groups of objects without reference to the cause of motion. Soccer handball can be connected to kinematics through the use of projectile motion by analyzing the action of throwing a ball in a parabolic arch towards another teammate to avoid the ball from being intercepted by the opposing team. While the ball is traveling across the court horizontally, it also experiences the same vertical motion as if it were to be thrown straight up. The throw of the ball in soccer handball would be a combination of constant horizontal motion and downward vertical acceleration. This is what results in a parabolic trajectory. In projectile motion, velocity must be broken into two vectors, vertical and horizontal velocity. By breaking up our velocity into two components, we are able to use them to solve for unknown variables like time and displacement. These are relevant to the sport as it would help one understand what velocity at the ideal projection angle of 45 degrees would allow one to reach one's target, and the amount of time it will take to reach the intended target to see if the other team would be able to make an attempt at intercepting the ball. The case I will use to further examine the effect of projectile motion in the sport of soccer handball will be the launching of a ball in a parabolic arch over the opposing team to reach my teammate. The ball is thrown at an angle of 45 degrees above the horizontal at an initial velocity of 15 meters per second. First, we will split the initial velocity into horizontal and vertical components by using the formula velocity initial in the y equals velocity initial times sine theta. For the vertical, and velocity initial in the x equals velocity initial multiplied by cos theta for the horizontal. Next, to solve for the time, we would use the velocity initial in the y, the final velocity in the y, and the acceleration due to gravity. The final vertical velocity would be equal to the negative of the initial velocity. Knowing these variables, we would be able to solve for the time by using the equation acceleration equals a change in the velocity in the y over a change in time, and rearrange it so we can isolate for delta t, making the equation delta t equals a change in velocity in the y over acceleration due to gravity. After solving for delta t, we will now be able to find the horizontal displacement of the ball by using the equation delta d in the horizontal equals velocity in the horizontal multiplied by delta t plus 1/2 acceleration multiplied by delta t squared. In this scenario, the acceleration is 0 because the horizontal velocity is constant. We will now be able to solve for the displacement using delta d in the horizontal equals velocity in the horizontal multiplied by delta t. Once this equation is used, it will be possible to find the displacement of the ball.
I will now explain how the kinetics aspect of soccer handball would change if it were to be played on another planet. If we are playing on Mercury, where the acceleration due to gravity is 3.59 meters per second squared, the normal force, or Fn, would decrease due to the smaller force of gravity. This would resultantly reduce the coefficient of friction, decreasing the overall frictional force acting on the ball. This would mean that the ball would take much longer to slow down when kicked than if you were playing on Earth. You would need to change the timing of your passes if this were the case. On the other hand, if we were to play on Saturn where the acceleration due to gravity is 11.08 meters per second squared, it would be the opposite to the Mercury case, and the force of friction would be much stronger than on Earth. This would cause the ball to slow down faster, meaning the passes and shots would need to be struck with greater force to reach their target.
On different planets, the momentum and energy of the game would change as the gravitational potential energy would change. Based on the gravity of the planet, it would increase or decrease the amount of stored energy in the object. For Mercury, its gravitational constant is much smaller than the Earth's at 3.6 meters per second squared, meaning when calculating for the gravitational potential of an object, it would be a smaller value. For Saturn, with the gravitational constant being larger than the Earth at 11.1 meters per second squared, it would increase the amount of gravitational potential energy the higher up the object is.
While being on other planets, the effects of acceleration due to gravity would drastically alter how the game soccer handball is played. If the sports were taking place on a planet like Saturn, where the force of gravity is much stronger, causing its gravitational acceleration to be much greater than Earth's, this would cause the time of flight to be reduced as it is inversely proportional to acceleration and thus cause the distance the object travels to decrease as well. On the contrary, if the sport were to be played on Mercury, the acceleration due to gravity would be much weaker than that of Earth. This would cause the time of flight of objects to increase and would also cause their distance traveled to also increase. To incorporate magnetic fields into our game, we would make the ball positively charged and we'd make the boundaries of the court a magnetic field. With the boundaries as a magnetic field, the ball would be repelled when shot out of bounds, therefore, the ball would always stay in play. There would be coiled wires built under the court following the basketball boundary lines. When there is a current running through the wires, it induces a magnetic field. When there's a sufficient amount of current running through the coil, that would induce a strong enough magnetic field. It could prevent the ball from moving out of bounds. When a wire is wound into a coil, then the magnetic field is greatly intensified, producing a static magnetic field. The magnetic flux developed around the coil being proportional to the amount of current flowing through the coils. This would mean that the strength of the magnetic field is determined by the ampere turns of the coil. With more turns of the wire within the coil, the greater the strength of the static magnetic field around it.